Hello, Mr. Soy here again. And this lesson is basically our last lesson in Chapter 8, where we're looking at how we can convert quadratic forms from one to the other. So, in other words, we want to look at how we can convert from standard to factored or standard to vertex, etc. First, I want to do a quick little review again of each of the three forms and some of the features that each have so that, again, this will help us understand each of the forms in more detail and will also assist you when you're trying to essentially convert from one to the other, especially if you're going to be using your calculator to do the conversion. But I'm going to talk about all the different methods that you can use. All right, so we've got our three forms here. We've got our standard form, factored form, and vertex form. And I've written them out in a nice generic general form. Ax squared plus bx plus c, that's our standard form. And we now know that if I wanted to solve this, if I set it equal to 0, my a, b, and c could be used in the quadratic formula to find my zeros or my x-intercepts. And the factored form, we have a times the quantity x minus r1 times the quantity x minus r2. And we now know that r1 and r2 are my roots of the quadratic if I set it equal to 0. In other words, the x-intercepts. And so we can immediately solve that quadratic just by looking at the equation and finding r1 and r2. And then finally, our vertex form, a times the quantity x minus h, quantity square, plus k, where we've learned that the h comma k is the vertex of our parabola, and from that we can find our line of symmetry and our minimum or maximum of the quadratic graph. Okay, so those are our three forms, and we're interested in how we can convert from one form to the other two forms. Okay, so let's list them out and go step by step. And in cases where we've already gone through it, I'll do a nice quick little example to demonstrate. All of them possibly could be done with your calculator, and we'll talk about that. And then a subsequent video will show you how to do those. But let's start with our standard form and how we can convert that to factored or vertex. Okay, so first one we're going to look at is standard to factored. And how do we convert that? Well, we've already done it. We've done it using factoring. And we looked at special cases. We looked at how we can use the generic rectangle. And we began to see some of the patterns that emerge that allow us to do that. We can also, it turns out, use our calculator, because with our calculator, we can actually graph the standard form of our quadratic and find the zeros. And once we have those, then we already know the roots, and therefore we can just put it immediately into factored form. One of the things I should highlight real quick is that in all three forms, the a term, or the leading coefficient, is identical for all three forms of any specific quadratic. And so once I have my standard form, I have the a for the other two forms. So really all I'm looking for in the other two forms, if I use a calculator, is my root r1, r2, or my hk vertex. So the calculator will have a subsequent video that'll show you how to actually do that pretty quickly. You've already seen it in a previous lesson. All right, so let's take an example of factoring to go from standard to factored form. And it's going to be a fairly easy one, but always good to see again. So an example, factoring. If I have the equation x squared minus 4x minus 5, then I'm looking for a pattern in here, And I'm not going to use the generic rectangle, but you certainly could use that technique with the diamond and solve it very easily. But I'm beginning, and I'm hoping that you're beginning to see some of the patterns that we have in here. When I don't have a leading coefficient here, it makes it quite simple. I'm looking for a number, two numbers that add to -4 but multiply to -5. Well, if it multiplies to -5, that means one is negative and one is positive. So I can immediately begin to look at the pattern of our factored form in the following way. I know that one of my numbers has to be negative, and I know that one of my numbers has to be positive. Well, what are the factors then of -5, or just 5 in general? Well, I have 5 and 1, and that's pretty much it. So 5 and 1, well, if I look at those, I can see that if one is negative and one is positive, the difference then would give me a 4. And since the 4 is negative, then my larger number has to be the negative number. So now I can simply write it in there as x minus 5, x plus 1. And since our leading coefficient in the first one we can see is 1, then I would just carry that down here as well. And so then this becomes our factored form of this quadratic going from standard form. All right, now we're going to look at standard form. And converting that into vertex form. Well, there's two techniques that you can use. You can use completing the square, which you have not learned. And I'm going to show you an example just because some students might be interested, but you're not actually responsible for knowing it, at least in Algebra 1. You'll learn that in a lot more detail in Algebra 2, but I'm going to show you an example anyway. And then, of course, we can use our calculator. And with our calculator, we already know that I can find the vertex. And once I find the vertex, I have h and k, and I can simply take that and go from the standard form to the vertex form, bringing my leading coefficient down into the vertex form, and I'm done. So the calculator method is a very easy, nice method. But I'm going to show you a quick example using completing the square. Some will be interested, but again, you're not responsible for this. Okay, so let's do an example. Let's do the, it doesn't really matter. Let's do previous one, x squared minus 4x minus 5. And in this case, I want to complete the square. And completing the square means I want to create my x minus h quantity square. That's what I want to do. And then whatever's left outside of that would then be the k. Well, think about it. This right here, well, I'm going to turn that into x minus h quantity square. And how I do that is called completing the square. So watch closely as I work through this. All right, so x squared minus 4x, and to make it a perfect square, well, I need to take half of this middle term, which is -4. I take half of that, I get -2. And then when I square that, -2 squared is a +4. So I'm now going to write a +4 inside my parentheses. That's awesome because that gives me then that perfect square, in this case, x minus 2 quantity square. Awesome. X minus h quantity square. The problem is I cannot simply just add a number into an equation. In this case, I added a +4. But if on the outside of my parentheses I subtract that same 4, well, now that's okay, because now I'm adding 4 and subtracting 4 in the same equation, right? Add 4, subtract 4, same equation. It's like adding 0. And that's okay. I can add 0 as many times as I want to anything. So now I've got my k term by combining these two numbers. Well, negative 5 minus 4 is going to give me negative 9. And lo and behold, I now have my vertex form h minus k, quantity square, minus 9. Again, if I'd had a leading coefficient here, well, then I would have had to do a little bit different, but I would just carry it down to here. And since it was 1 there, 1 here, we are done. And we have actually converted from standard form to vertex form. We'll show you how to do it with the calculator later. All right, now we want to look at going from vertex form to standard form. Well, vertex form to standard form, it turns out that I can simply square and distribute. And I'll do an example of that. And that will essentially, and once I combine my like terms, that'll essentially convert it from vertex to standard. Now, doing it on our calculator, that becomes a little bit tricky, but essentially it can be done because I know I can find my y-intercept on the calculator, and so I at least have the c term. But how do I find then that other piece of it? That's not quite so straightforward. So really, this is the main process that you want to use if you're going to convert from vertex form to standard form. So let me show you. We're going to use the example in this previous problem, so we already know what the standard form looks like. Okay, so here we go. Our example, x minus 2 quantity square minus 9. So square, that means I take my x minus 2 and I simply square it in the following way. And then I'm going to distribute. I'm essentially going to multiply this binomial to this binomial. Okay, so let's do that. I end up with x squared minus 4x plus negative negative plus 4. Just basically distributed my x through the second and then the 2, and that's what I ended up when I collected my like terms. And now I have a minus 9. Then really our last step is to combine our like terms, and I have x squared minus 4x. Well, plus 4 minus 9 would give me a negative 5, and I'm done. And that's all we have to do to convert from vertex to standard form. All right, now we're going to look at how we can go from vertex to factored form. And it turns out there's two different ways that we can look at it. The first is we can first convert to standard. And factor. That's one method. But of course I can also use my calculator. And the reason I can use my calculator is because when I graph the vertex form of my quadratic, well, I now know how to find the zeros of that graph. Well, that's my R1 and R2. I already have my leading coefficient in the vertex form, and so now I just plug those two things in and I've got it. And so a later video is going to show you how you can do that. So that's actually pretty straightforward and simple. Converting to standard, we already know how to do that. And then factoring, in other words, standard to factored form, well, we know how to do that as well. And so those are really the two methods. If you're given it in vertex form and they ask for the factored form, that's how you're going to do that. All right, so now we're going to look at factored to standard. All right, well, the main way is really just distributive property. I'm just going to multiply it out, combine my like terms, and I've got it. It's just the distributive property. That's pretty easy and straightforward, and I'll do another example of that. And then factored form to standard form. Calculator, that gets a little bit tricky. Again, I can find my y-intercept, but there's really not a great way for me to be able to then find the rest of the terms that I need, to the a and the b term. I mean, I have my a in the factored form, but that b term gets a little bit tricky. So really the distributive property is our primary way that we want to be able to convert from factor to standard. And let's just take another peek at that real quick. So I'm just going to do an example. Let's say I have 3 times x minus 4 times x plus 6. And distributive property tells me I'm going to distribute to get rid of my parentheses. So distributive property, x times x, x squared, x times 6, 6x. Then I go to my second term, negative 4 times x, negative 4x, negative 4 times 6, it's negative 24. So I can just do that here real quick, and then when I do that, I end up with the following. X squared, that's x times x times 6 is 6x, negative 4 times 6 gives me negative 4x, sorry, negative 4 times x, and then negative 4 times 6 gives me negative 24. So there I've used the distributive property. Now I will combine my like terms, the two middle terms, and that gives me a x squared plus 2x, 6x minus 4x is 2x, minus 24. And I'm not done because I still have my leading coefficient here, and I'm just going to distribute that to all three terms inside the parentheses, and I'll be done. So 3 times x squared is 3x squared, 3 times 2x is 6x, and 3 times 24, and it's negative, is going to end up giving me 72, and I'm done. I have then converted from factored form into standard form. Well, our last conversion that we need to look at is going to be our factored to vertex. And for this, there's really two processes. One is I can convert to standard, and then complete square, which I demonstrated, but I don't expect you to know that. Really, the best way is going to be your calculator, because once I have my factored form, I can put factored form into my calculator, and then I can find my HK, which is essentially my vertex. I've got the leading coefficient already, and I just plug them in and I have that. And a subsequent video is going to walk you through that process. That's it. Thanks.